The world of artificial intelligence isn't some, far-off sci-fi concept anymore. It's really here, and it's embedding itself deeper and deeper into how companies operate every single day.
Absolutely. And with that, well, comes this critical need, doesn't it? The need for very specialized skills to make sure these really complex systems are running correctly, securely, reliably.
Exactly. And that's where the auditor's role takes this, well, fascinating new turn. Welcome back to the deep dive.
It's true. I mean, as AI shifts from the lab bench into like daily business handling customer queries, optimizing supply chains, maybe even making significant financial calls, getting a handle on its operational reality is just
Dude.
crucial.
Yeah, it's not just theory for auditors. It's about looking under the hood, seeing how AI actually works in the wild, and figuring out how to manage its a very unique set of risks and challenges. And that's exactly what we're digging into today. We're cracking open Chapter 2 of Isaaca's Advanced in AI Audit Official Review Manual. Now, this chapter, it's the heart of what they call AI operations. It's where we get down to the nuts and bolts of how AI solutions are actually deployed, monitored, maintained, secured, after they're built.
Right.
We're going to zero in on the chapter overview first, and then really get into the weeds with Part A, which tackles the absolutely fundamental topic of data management, specifically how it's different for AI.
Yeah, think of this as like your guided tour through this really essential material. We're here to help you navigate it, point out what's most critical from an auditor's viewpoint, and, maybe translate some of the heavier technical stuff into clear, practical insights.
Right. The goal is to help you understand the why. Why are these requirements here? What does an auditor actually do when they encounter an AI system out there in operations?
Exactly. We'll stick to the manual structure, going section by section, just to make sure we build that foundation properly.
Okay, ready to unpack Chapter 2.
Let's do it. So the big picture first.
Yeah, let's start there. Chapter 2, AI operations. What's the overall scope?
Okay, so chapter 2 is all about that operational life cycle, right? It's not the initial brainstorming or, the deep academic theory of model building. It's what happens after development. How does it get into production? How do you keep it running smoothly? How do you track performance? What happens when things go wrong?
And from an audit perspective.
That's where so many practical risks and control considerations really pop up. It's the day-to-day reality of the AI.
And this isn't just a side note in the manual of it. I mean, the weight it carries on the exam really tells a story.
Oh, definitely. If you check the exam outline domain 2, which is AI operations, it makes up a whopping 40% of the exam content.
40%.
Yeah, it's the single biggest domain. That tells you ISO views these operational aspects as, well, probably the most critical area for an AI auditor to really get their head around. You can see that breakdown back on page 173 in Appendix A.
Wow, 40%. So if you're prepping for this exam, this chapter is clearly where a huge chunk of your focus needs to be. It's the practical side of AI auditing. And the manual breaks down what's in that 40%.
It does. On page 77, it lists the key areas under Domain 2 AI operations. Let's see.
Go for it.
Okay, first up, where we're starting today. Part A, data management specific to AI, super fundamental, as we'll see.
Right.
Then there's Part B, AI solution development methodologies and life cycle, so how they're built.
Okay.
Part C is change management specific to AI. How do you handle updates to models or the data feeding them?
Critical.
Part D covers supervision of AI solutions, basically monitoring outputs, impacts, decisions, watching what it does.
Makes sense.
Part E gets into testing techniques for AI solutions. How do you actually test these things?
Which can be tricky.
Very. Part F looks at the unique threats and vulnerabilities specific to AI, the security angle.
Okay.
And finally, Part G deals with incident response management specific to AI. What do you do when it breaks or gets attacked?
So it really is the full journey, isn't it? From the data going in, through the build, managing changes, watching the output, testing, understanding the unique security risks, and then knowing how to react when things go sideways.
Exactly. And all through that auditor's lens.
And the manual doesn't just list the topics, it tells us why auditors need this knowledge.
Yeah.
It lays out specific learning objectives or task statements, also on page 77. These are the skills you're meant to walk away with.
Precisely. These objectives really define what an AI auditor needs to be able to do in this domain. They're super important because they frame the entire chapter. Let's look at a couple.
Yeah, please do.
Okay. One is about evaluating the impacts, opportunities, and risks when you integrate AI into the audit process itself. So using AI as an audit tool, how does AI change auditing? What are the risks of relying on AI in an audit?
Interesting. So AI auditing AI.
Kind of, yeah, or at least using AI in the audit. Related to that, another objective is actually utilizing AI solutions to enhance audit procedures. So understanding how AI can make audits faster or broader or analyze massive data sets in ways we couldn't before.
Got it. Practical application.
Then there's evaluating identity and access management for AI solutions. Basic security, but how does it apply to AI components, the data, the models, the dev environments? Who gets access to what?
Standard, but with an AI twist.
Exactly.
Okay.
And a big one, evaluating the role and impact of AI decision-making on the organization and stakeholders. AI outputs can have major consequences, right?
Right.
So auditors need to assess if those decisions are appropriate and if the impact is understood.
That feels really important.
It is. Then evaluating the organization's AI policies and procedures, including compliance. Do they have rules for AI? Are they following them? Are they meeting legal requirements? Basic governance. Auditors also need to evaluate how AI-specific metrics are monitored and reported. Things like KPIs for performance, KRIs for risk. How do we actually know if the AI is working well or if trouble's brewing?
Performance and risk tracking.
And this last one ties right into where we're going next. Evaluating data input requirements for AI models, looking at data appropriateness, bias, and privacy. This really hammers home that checking the data fueling the AI is a core task for the auditor.
That's the perfect segue to Part A, isn't it?
Yeah.
It spells out that data isn't just some technical footnote. The auditor has to evaluate it because it fundamentally shapes everything the AI does.
Yeah.
Before we jump into Part A, though, I noticed the manual also points to other resources on page 78, IE standards, ISO stuff, ISO's own tools.
Yeah, that's a good point. It shows this isn't happening in a vacuum, right? AI auditing is building on established frameworks, but also creating its own specific guidance. It's a developing field.
And it has those self-assessment questions read the overview, too, which I found pretty helpful.
Oh, yeah, those are great for checking your understanding. They really make you think.
They do. They're often not just about recalling facts, but asking for the best or most likely approach, forcing you to apply the concepts like an auditor would. Let's maybe walk through one or two from pages 78 to 80.
Sure, good idea.
Okay. Question 1 is about bias. It paints a scenario where an AI is showing gender discrimination in its decisions and asks what type of bias is the likely culprit. The options are systemic, statistical, human, and overfitting.
Right. And the answer key points to systemic bias. This is a really key distinction for auditors. Systemic bias, it comes from, well, established procedures, policies, or crucially for AI, biases that are already present in the training data.
So historical bias in the data gets learned.
Exactly. If the data reflects past gender biases, the model learns that pattern and just keeps repeating it. That's systemic. Statistical bias is different. It's more about errors in sampling or how data is represented that might lead to inaccurate statistical findings, but not necessarily that deep-seated discrimination.
And human bias.
That relates to individual judgments, which matters, but it's not the root cause when an automated AI system is reflecting its training data. And overfitting, that's a model training issue where it works great on the training data, but fails on new data again, different from systemic discrimination baked into the data.
So an auditor investigating discriminatory AI outputs would look first for systemic bias in the data or the processes feeding it. That makes sense.
Precisely. Understanding the types of bias helps you know where to look.
Okay, question 2 flips to change management for AI. It asks what you need to maintain the accuracy of an AI's output when the data it sees changes over time. Options were data drift monitoring, regularly updating parameters, minimal testing after changes, or hardware upgrades.
And the best answer there is establishing data drift monitoring mechanisms. This hits on a core idea in AI ops. The world changes. The data the AI sees in production can shift customer behavior changes, the economy shifts, whatever. That's data drift.
Right.
If the model was trained on old data patterns and the new data drifts away, its predictions get less accurate, sometimes silently. Data drift monitoring detects these changes in the input data compared to the training data. It flags it, maybe triggers retraining.
So just tweaking parameters isn't enough?
Not if the underlying data reality has changed. It's like tuning an engine without realizing you've put diesel in a petrol car. Minimal testing, definitely not enough. Hardware upgrades, irrelevant to the data itself. So for an auditor, checking for effective data drift monitoring is key to assuring ongoing accuracy.
Data drift monitoring. That's definitely an AI-specific term auditors need in their vocabulary. Okay, one more question 3. On securing generative AI against prompt injections. What's the best way to improve security? Options. Robust access controls on data, regularly updating the model, using input template sanitization, or enhancing endpoint security.
This one's interesting. The manual says the best answer is implementing robust access controls on data sources. Now, prompt injection happens at the input, right? You craft a sneaky prompt.
Yeah, seems like input controls would be the direct answer.
But the explanation makes a good point. The most foundational control for protecting the whole AI solution, including against attacks like prompt injection, is strong access control. If attackers can't get unauthorized access to the system or the data sources that GenAI uses, a lot of attack paths just vanish.
Ah, I see. It's about the first line of defense.
Exactly. While updating models or using input templates are specific defenses against prompt injection, access controls are more fundamental. They stop unauthorized folks from even trying or from accessing sensitive stuff through an injection if they managed it. Endpoint security is too broad, so auditors assessing overall security look at those foundational access controls first.
Okay, that makes sense. It's about evaluating the layers of security, starting with the foundation. These questions really drive home that applied thinking, it's not just memorizing terms, but understanding why a control is effective in an AI context.
Absolutely. Understanding the reasoning is what makes you effective, both for the exam and, in the real world.
Okay, I think we've got a really good handle on Chapter Two's scope now, its importance, the skills it covers, even how Isaac could test it. We know AI operations is about the AI's life after development, and data is absolutely central. So let's make that transition. Let's zoom right in on the first big piece, Part A, data management specific to AI.
Right. And data management is the logical place to start because, well, data is basically the food, the fuel, the lifeblood of any AI system. Models learn from data. They often keep processing new data in production. So the quality, the availability, the security of that data, it's absolutely fundamental to everything else. Performance, reliability, fairness, and ultimately whether you can even trust the AI.
And it's not quite like managing your standard company database, is it?
Yeah.
The manual points out that AI systems can be these sprawling things, models, data stores, workflows, all interconnected. Managing data across that kind of landscape just sounds way more complex than traditional IT data management.
Oh, it absolutely is. Much more complex. So let's follow the manual structure here in Part A. It starts, logically, with the first step in the AI lifecycle, referencing figure 1.10 back on page 32. That first step is 2.1 data collection.
Data collection, where it all kicks off for a data-hungry system.
Exactly. This is where you gather the raw materials from wherever they live. And this data isn't just one monolithic block, it gets split. You have your training data, which the model learns from. Then validation data used during training to fine-tune things and stop it just memorizing. And finally, testing data, completely new data used after training to see how well the model actually performs in the real world, so to speak.
And the manual flags several key questions an auditor needs to be asking about this initial collection phase.
It does. As an auditor, you should be digging into what specific data was actually pulled, how is it represented, what format, structure, any cleaning or changes made. Crucially, was consent properly obtained, especially if it's personal or sensitive data? And did the collection process itself introduce risks, like sampling bias that could lead to overfitting, where it knows the training data perfectly but nothing else? Or underfitting, where it just didn't learn enough?
Okay, let's pause there. You said this is especially critical for AI. We collect data for traditional systems all the time.
Yeah.
Why the extra layer of scrutiny here?
That's a really core point for an auditor to grasp. In a, let's say, traditional accounting system, bad data might mean an incorrect invoice total or a flawed report.
Yeah.
Right? Often traceable, often correctable.
Right.
But in AI, especially machine learning, the data is what the model learns from. It shapes its entire understanding of the world. If that data is poor quality, biased, unrepresentative, the model learns those flaws directly. It's not just a data entry mistake. It's like corrupting the AI's brain during its education.
So biased data leads to biased decisions.
Directly. And if that AI is making decisions about hiring or loans or medical diagnoses, the consequences can be huge: ethical, legal, reputational. So the auditor has to verify that this foundation, the data, is sound, appropriate, and gathered responsibly, because fixing problems baked in at this stage, it's incredibly difficult later on.
Okay, that makes the risk profile totally different. The data isn't just stored, it's actively shaping the system's logic. Which leads naturally into the next section, 2.2 data classification.
Yeah, classifying data based on sensitivity, confidential, internal use only, public, etc. That's standard security practice. But again, AI adds layers. You need to identify sensitive internal data, maybe intellectual property. That's going into the training mix.
And the manual highlights the risk when sensitive stuff is in that training data. how do you keep it confidential throughout its journey?
Exactly. And here's the AI twist. Training often means churning through huge amounts of data repeatedly. And information from that data can get, well, sort of implicitly encoded or learned by the model itself. So the question becomes, how do you make sure someone can't somehow infer or reconstruct sensitive details from the model or its outputs later?
So the model itself could leak info.
Potentially, yeah. Traditional classification helps label the data, but for AI, you need to think about preserving that confidentiality during the learning process and within the resulting model. Auditors need to check if the classification policies actually address these unique AI-specific risks.
So it's not just labeling a file. It's understanding if the AI system itself might breach confidentiality. Which brings us straight to 2.3 data confidentiality. The manual's pretty clear. This needs to be maintained across the entire AI development lifecycle.
Right. And figure 2.2 on page 83 does a good job visualizing this. It shows different spots where data lives and the controls needed. Well, at the raw data location where it starts, you need basic stuff like restricted access, need to know. Then in the data lake, where you pool tons of structured and unstructured data, you need detailed classification, sensitivity levels, strong access controls, because that lake is a juicy target for attackers.
Makes sense.
Then there's the data exploration training platform. This is where data scientists are actively working with data notebooks, documents, images, whatever. It's often less controlled than, say, a production database, so confidentiality controls here are really important.
And even vector databases.
Yeah, even those. They store data as mathematical vectors, right?
Right.
Like embeddings. You need to control who can access or query these vectors because they still represent the underlying information.
So that figure shows data moving and changing form, needing controls all along the way. The text adds more detail too.
It does. It notes that training data is often huge, needing lots of storage and processing power that expands the security surface auditors need to look at. The encoding into vectors or embeddings, that's a transformation that needs understanding these aren't just files, they're math representations, and they need protection. The sheer concentration of data in lakes makes access control vital. And the manual also mentions data validation policies, centralized security for replicated data.
And embedding confidentiality right into the design phase.
Absolutely. Not as an afterthought. A really tricky bit for AI, though, is that models often need data in specific formats, sometimes unencrypted, for processing. This messes with simple encryption at rest or in transit.
So how do you handle that?
Well, there are advanced techniques like homomorphic encryption, page 86 mentions it, which lets you compute on encrypted data. But the manual rightly points out it's often computationally expensive, so maybe not practical yet for everything. So auditors need to look at that trade-off. How does the organization get the data utility needed for training powerful models while still maintaining confidentiality, especially when data has to be decrypted for processing? It's complex. The scale of AI data often means traditional security needs rethinking.
So the auditor's evaluating that balanced data utility versus secrecy, knowing standard controls might not be enough alone. Okay, after protecting data from prying eyes, what about just not losing it? Section 2.4, data backup.
Right, backup. Foundational IT control, just as vital for AI. You obviously need to back up the original data used for training, testing, validation. And store those backups securely, maybe offsite, separate. Standard stuff.
But for AI, it's not just the raw data that needs backing up, is it? That seems unique.
That is a crucial difference. For AI, you don't just back up the data. You must also back up the model architecture itself, its definitions, its parameters, basically, the trained model.
Why?
Two key reasons: reproducibility and explainability. Reproducibility means you can recreate that exact version of the model later if you need to, maybe for an audit check or debugging or consistent deployment. Explainability means if that specific version of the model made a controversial decision, you might need to load it up again to understand its internal state or logic at that moment.
Ah, okay.
And you also need to back up the specific training and testing data sets that went with that model version. This lets you re-audit data quality, rerun performance tests, or analyze bias related to that specific iteration. So an auditor checks, does the backup policy cover the data in these critical model artifacts?
That's a great point, backing up the learned intelligence, not just the source books. Okay, ensuring the data is accurate and trustworthy leads us to 2.5, data integrity.
Yeah, data integrity, hugely important in AI. It means ensuring all the data used for training, validation, testing, and also for running the model in production, inference, is accurate, complete, consistent, reliable. If the data lacks integrity, the AI's outputs, which are totally data-driven, simply can't be trusted.
And the manual brings up that operational concept we had earlier, Data drift.
Yes, data drift is a major integrity threat. Remember, it's how real-world data changes over time compared to the training data. It's not necessarily malicious, just reality shifting. But if you don't monitor and manage it, the model's integrity, its accuracy, and reliability degrades over time. Auditors need to check for controls to detect and handle data drift.
And integrity can also be deliberately attacked, right? The manual lists some AI-specific ways.
It does. This highlights the unique threat landscape again. Key integrity attacks include data poisoning. This is sneaky. Attackers inject malicious, maybe subtly flawed data into the training set. The model learns from this poison, and its behavior can be skewed or backdoors introduced. It might fail in specific ways the attacker wants. Auditors would look for strong data validation and source checks here. Model tampering. This is more direct, actually modifying the trained model's weights or structure to make it produce wrong or biased outputs, like messing with the AI's brain after it's trained. Embedding tampering. For models using embeddings, attackers might fiddle with those mathematical representations to skew results.
Let's break that down. How is data integrity risk in AI really different from, say, finding a wrong number in a sales database?
Well, in the sales database, a wrong number is just a wrong number. It affects that record, maybe a report. With AI, especially data poisoning, the attack targets the learning process itself. The attacker isn't just changing one data point, they're teaching the model the wrong lesson. The bad data gets learned, becoming part of the model's logic. This can cause systemic errors or hidden malicious behaviors that are way harder to spot and fix than a simple data error.
So auditors need to think beyond just checking if data was stored correctly.
Exactly. They need to consider the integrity of the data as an input to learning. And the manual references ETL processes, extract, transform, load later on page 156, but it's relevant here. Robust ETL with strong data validation and cleaning is a key defense against integrity issues before the data even gets near the training process.
Right. ETL as a preemptive integrity control. Makes sense.
Okay.
Moving on. 2.6 data sourcing. Where does the data come from?
Yeah, this section is all about provenance. Is the data internal, collected by the organization itself, or external bought from vendors, scraped from the web? Auditors need to know because external sources bring specific risks.
Like what kind of risks?
Well, quality is a big one. You have less control over how external data was gathered or cleaned. Bias is another huge concern. External data sets might carry biases from their original context that you don't know about or that don't fit your use case. And IP rights, are you actually allowed to use this data? The manual stresses the data sourced must be appropriate for the specific AI task. It's not just about quantity, it's about suitability.
And getting the sourcing wrong directly impacts the model's performance and risks, doesn't it? The manual connects this to several factors.
Absolutely. The data source heavily influences generalization, how well the model works on new, unseen data. If your training data isn't representative, generalization will be poor. Interpretability. Understanding why a model makes decisions can be tougher if the source data is a black box itself. Computation costs. Messy, large, or poorly structured data just takes more horsepower to process. Overfitting, underfitting. These common training problems are directly linked to how appropriate and representative the training data is. Bias. We keep coming back to this, but it's crucial. If the source data is biased, the model learns that bias. Auditors have to evaluate the process for vetting data sources.
So understanding data origins isn't just a checkbox. It's core to assessing the AI's reliability and fairness. Okay, once you have the data, you need to control who gets to touch it. Section 2.7, data access.
Yep, standard security pillar, access controls. Absolutely critical for AI data. The principle is always need to know, or least privilege. Only people or systems needing access for a legitimate reason should have it.
And data lakes seem to make this harder because they centralize so much.
They definitely do. Data lakes are great for making data available, but they consolidate risk. You need really granular controls inside the lake, not just at the edge. You can't just give every AI developer keys to the whole kingdom. Access needs careful segmentation by role, project, data sensitivity. And these controls are needed everywhere. Data prep areas, training platforms, production systems. Auditors check if AI data access plugs into the main company IAM policies.
And the manual brings up that confidentiality point, again, needing data unencrypted sometimes, even with access controls in place.
Yeah, it's that persistent tension. Access controls stop unauthorized users, but the AI model itself might need decrypted data to work. So you need other layers, maybe monitoring the processing environment, ensuring the AI system has minimal permissions, perhaps using privacy-enhancing techniques like differential privacy alongside access controls. The auditor looks at the whole package.
A layered defense. Okay, speaking of word training habits, 2.8 development environment.
Right. Training AI models often needs special environments, lots of data, powerful GPUs maybe. The manual stresses using non-production environments for this.
Why is that separation so important for AI dev?
It's fundamental security hygiene. Using real production data, especially the sensitive stuff, directly in a dev environment without strict isolation. That's a huge risk. Non-prod environments let developers work with data that's either real but tightly controlled and segregated, or even better, synthetic data that mimics real data patterns without the actual sensitive info. And these environments need strong security themselves: network isolation, access limits, monitoring. Auditors check if the organization has secure AI dev environments and enforces controls there.
Isolating the lab. This flows right into a major theme. Building security and privacy from the start. 2.9 privacy and security by design.
Yes, a really critical concept, especially given how data-hungry AI is. Privacy and security by design means thinking about and integrating these aspects right from the beginning, during design, and keeping them in mind throughout the whole lifecycle, not trying to bolt them on afterwards.
The manual mentions privacy by design. Maybe not all 7 principles in detail here, but the core idea.
Right. The core ideas are there. Be proactive, not reactive. Make privacy the default. Embed it in the design. Ensure full functionality with privacy. Provide end-to-end security. Maintain visibility and transparency. And respect user privacy. It's making privacy a fundamental requirement.
And security by design is similar build-in defenses from the start, anticipate threats.
Correct. And the manual directly links this to big privacy laws like GDPR and CCTA, referencing Figure 1.31. AI systems, because they use so much data, must be designed to comply with these rules.
Which ties back to those privacy considerations from earlier: transparency, fairness, explainability, consent.
Exactly. Designing for privacy means designing for transparency. How's data used? Fairness. Does it lead to bias? Explainability. Can we understand the AI's reasoning?
Yeah.
And ensuring proper consent. An auditor looking at this would want to see evidence that these were actual design considerations, not just words in a policy document.
Let's analyze this. AI uses vast data sets. How does that make privacy and security by design both harder and more important?
Well, it's harder because AI learns complex, often opaque patterns. Ensuring sensitive attributes don't sneakily influence decisions, or that the model doesn't accidentally memorize and leak individual data points. That takes sophisticated techniques. Things like differential privacy, adding noise carefully, or secure multi-party computation, computing on data without revealing it, are complex and can affect accuracy or cost. Doing it right from the start needs real expertise.
Okay, so it's technically challenging, but why more important?
Because the potential harm is magnified by the scale. A privacy breach or security flaw involving huge AI datasets can impact vast numbers of people. Biased or opaque AI decisions derived from data handled without privacy baked in can lead to major legal trouble, destroy user trust, ruin reputations. The risks of not designing privacy and security in Login are just much, much higher with AI compared to many older systems. Auditors really need to scrutinize the organization's commitment here.
It sounds absolutely foundational. Okay, finally, in this data management section, the manual talks about 2.0 attacks on AI.
Yeah, because AI systems aren't just vulnerable to standard cyber threats. They have their own unique attack surfaces. These often target the model, the data, or the training process itself.
And these can happen at various stages, right?
Yeah.
The manual points to later figures, 2.13 and 2.14, that list common attacks and defenses.
Exactly. Some key AI-specific attacks mentioned are prompt injection, big one for LLMs, crafting input prompts to trick the model into doing things it shouldn't, like bypassing safety rules or revealing info. It's manipulating the AI through its input instructions. Data poisoning. We talked about it under integrity, but it's a deliberate attack too. Slipping bad data into the training set to sabotage it or create backdoors. Adversarial inference evasion. Creating inputs that look normal to humans but are slightly tweaked to fool the AI into making a mistake, like misidentifying an image because of tiny hidden patterns.
And auditors need to understand these threats and the kinds of detection and eradication techniques listed later.
Yes, because evaluating the controls against these specific attacks is part of the job. Now, why are these different from traditional hacking? Traditional attacks might go after the OS, the network, the app code to steal data or cause downtime. These AI attacks often target the logic of the model, the data it learned from, or how it makes predictions. They exploit how AI learns.
So they need different defenses.
Absolutely. Defenses like strong input validation against prompt injection, rigorous data pipeline checks against poisoning, or special adversarial training to make models more robust against evasion attacks. This means the audit focus has to be different too. You can't just check firewalls and patching. You need to look for these AI-specific controls.
That difference is key. Standard cyber controls might not cut it. Auditors need to look for defenses tailored to AI's unique vulnerabilities.
Precisely. It's a whole new layer of risk to manage.
So, wow. As we've gone through Part A, it's crystal clear that managing data for AI is way more involved than just database administration. It covers everything from collection, classification, keeping it confidential across complex systems, backing up not just data but the models too, ensuring integrity against weird attacks like poisoning and drift, vetting sources for bias, controlling access carefully, securing dev environments, and really embedding privacy and security from the absolute beginning.
This section really does lay the critical groundwork. If the data isn't right, if it's not handled securely, privately, ethically, then the AI built on top of it is going to inherit all those problems. Doesn't matter how clever the algorithm is.
This deep dive has hopefully given you a really solid foundation in these crucial data aspects of AI operations, viewed through that auditor's lens. You should now have a much clearer sense of what an AI auditor needs to probe when looking at the data powering these systems, the unique risks, the essential controls, and why proactive design is so vital.
And understanding these data challenges really sets you up for the next parts of Chapter 2. They build right on this, covering how models are developed, how changes are managed, how outputs are supervised, how testing happens, how incidents are handled. It all connects back to the data.
As we wrap up this part, here's something to chew on. Given how absolutely fundamental data is to AI and these unique evolving risks, including subtle attacks that poison the learning itself, how are auditors going to ensure the ongoing trustworthiness of the data feeding these ever more autonomous systems down the road? What completely new verification techniques might we need, beyond just checking database entries, to be sure the data hasn't been subtly corrupted or biased in ways that are really hard to spot with today's methods?
That is a huge, complex question. It's definitely going to shape the future of AI auditing and demand some real innovation in how audits are done.
Indeed. Well, thanks for joining us for this deep dive into Chapter Two's overview in Part A of the ISAC Advanced in AI Audit Manual. We really hope this has been a helpful step on your learning journey.